Right then, well, we might as well crack on. So, behaving like a Git and getting away with it. How many people here use Git in the day-to-day environment? Brilliant. How many people think they understand how Git works? A couple, okay. How many people get scared by Git? That's what I thought. So the whole reason why I put this talk together was because I kept on going into environments, kept on working with developers who were scared to the back teeth of Git. They get it dumped on them, management turns around to them and says, right, we're doing everything in GitHub now, or we're going to use Bitbucket. And the developers turn around and go, yay? And they're expected to understand how the thing works to start with. So that's the level of this talk. Want to try and do is demystify the processes behind the scenes, and hopefully that'll make life easier to work with. Okay? So I am a technical architect and evangelist. Those people who've seen my talks before will know this, will have seen this bit before. I've been developing for way too long. Properly started on one of those before migrating to one of these. Then moving on to one of those. Awesome. Mega, fantastic machines. And then made the giant leap forward to, yeah. Anyway. I'm a very, very infrequent blogger. It's more often than not you'll find tumbleweed, but I mean, if there's anything there that you find useful, please knock yourselves out. But don't expect any updates for very extended periods of time. So, what is Git? Well, in its basic form, Git is a distributed version control system. But you already knew that. So what do I mean by distributed version? Well, who here has come from a background of using things like Subversion, right, or Team Foundation Services? Brilliant. So the difference between Git and TFS is it's disconnected. Git, when you work with Git, you are working with a complete copy of a repository. Whenever you grab a repository down from the internet, you are grabbing everything. You are grabbing all the history, all the work that's been done to it, and you're bringing it down locally to your machine. It's completely disconnected. Unlike things like Subversion or Team Foundation Server, where you are liaising with a central authority all the time. Okay? So in Subversion, you check out a copy of the code at a point in time. You make your changes, and then you submit those changes. So you submit the delta. With Git, you do it all locally. So you pull everything down, and you make your changes in your local system, and you may or may not want to share that with the outside world. But the great advantage is that you could be on, once you've got the repository down, you could be sat on the train with a rubbish Wi-Fi connection. You don't need access to the outside world. You can traverse through, you can branch, you can do anything anything you need to do is done locally on your local file system. Okay? So it was created by Linus Torvalds. The Linux kernel codebase was originally being maintained in a system called BitKeeper, and there was a falling out with regards to licensing issues. So he used BitKeeper as the basis, as an inspiration, along with things like Monotone, to produce this distributed version control system. So Linus being the nice, friendly person he is, yes, it has all the hallmarks of it being slightly obtuse at times. So how do we get started with Git? Get in it. That's it. That's the only thing you need to know to get going. When we do a Git init, so a Git init repo, for example, we create a folder, and in that folder there will be a .git folder. So effectively what we end up with is a structure like this. So you have a folder, and inside it there is a magic folder called .git. And that magic folder is the repository. Okay? That repository right there, that's it. So all the history and everything else is going in that location. Okay? So
is that on the server?
it's on wherever you're doing it. So for example, here I have a PowerShell session, and I have a few things in there. So let's git init demo. Done. So my machine now has a fully initialized Git repository sitting on the machine. And I can go, sorry, and I can go into it. And with the PowerShell extensions I've got installed, so I'm running the posh Git extensions, it tells me that I'm on the master branch. Done. You can see this, so there is the Git folder there. Normally it's hidden, but that's it. That's where it is. And every commit, every operation that you do actually happens in there. So you can also create, this is a normal local working copy. You could also create a bare, so I could do this. And sorry, I should have actually done that. By convention, when you do a bare one, you call it .git, like that. And what you've got here is a raw repository. So this is where you would normally what you would normally store on a server, where you're not actually doing any local work. So a bare repository is just the commits. It's not actually, it's no working version. But generally, locally, you simply start with a working copy. Okay? So you just do a git in it. If you've already got a tree structure, if you've already got a location that has all your source code in it, just do git in it. So you don't even have to create it will create it in place for you. So let's say I had a just go into existing, and I can just get in it at that point. And I've just done it again. So there we go. Creating repositories is simple, is incredibly lightweight. You can do it for anything. Do it for your PowerShell scripts, do it for your modules, do it for your local home folders, do it for anything. Anywhere you think that you might need some source version control, do it. It takes seconds. Yeah? So, we've got our folder. It's got its magic Git folder in it. So let's put some stuff in it. In this case, I've just simply asked for the status of the repository. It's empty. There's nothing there. There's nothing to commit. We're a completely blank working copy. So if I do this here, so I'm in my demo repository, and I'll just do a git status. This command you'll get to love. Okay? Notice that the typo was a deliberate mistake. Git does actually do quite a good job every now and again of trying to work out what it was you were actually typing, and will attempt to prompt you if you've got it wrong. But anyway, so the status is telling me that I'm on the branch master on the initial commit, and there's nothing to commit. Okay. So what we're going to do is so that's our state there. So imagine this is a tree growing up from the bottom. That's the state we're at now. We're at sort of an initial node. Okay? And what we're going to do is add another commit to it. So we're going to add another step to the tree. Okay? So, this is easy enough. Let's just In fact, where's my snippets file? I have my favourite thing in the world at the moment, which is horseebooksipsum.com. If you want any, yes, this is genius. If you want any, Lorem Ipsum is so 90s. If you want anything decent, use a horse ebooks. See what I mean? So I'm going to pipe this through into a README because that would make sense. So here's the contents of the README file. Okay, it's complete gibberish, it's brilliant. But it looks fairly real. So I have a README file. Now if I look at my status, it's telling me I'm on branch master, I'm on the initial commit, and there is an untracked file. There's an untracked file called readme.md. So what I need to do is I need to track the file. I need to put it somewhere where I can stage it before it gets to commit. So this is the other major difference between working with Subversion TFS or Git. Generally in Subversion, you would make your changes and you commit the changes, right? In Git, you stage them. So you have a working area, so your folder. You have this stage, or sometimes referred to as the index, or even the cache. The terminology is used interchangeably, where you put together what your commit will look like, right? And then you commit that. So what I'm going to do is I'm going to add this file to my staging area. Okay? So I'm going to do that with git add readme.md. Okay? Now, LF would be replaced by CRLF and readme.md. I will come on to this. This is something that bites a lot of people. But I will come on to this. For now, just accept that that's okay. And what I'm going to do is git commit with a message, and that message is going to be add readme. Sorry, hang on. Yeah, I am going to need to, sorry, bear with me just 1 second. Where's my folder gone? So this is a problem to do with line endings. And that ebooks, I hadn't realized, does something nasty with it. So I'm just going to quickly reset the encoding on this. Encoding, where are we? EOL conversion, there we go. Windows format. Save it. Okay, let's add that again. There we go. So the prompt here, my posh get prompt has gone green. And what this is saying is that I'm on branch master, I have an initial commit, and I've got some changes to be committed. Okay, so my staging area now has, so this virtual idea, this virtual stage, now has a file that will be committed when I do the commit. Okay? And so I'm just going to make that commit done. So it's inserted the file, and I've now got something in my log. So I could git log, just put one line because it's, and there we have it. The Git is there, it's in our working copy, it's in the file system, right? Are we happy with this? This all makes sense. Good. So if we looked at, take a note of this number here, this A7B3. This is the SHA, this is the commit number, all right? This is the hash. Again, this is a term that's used interchangeably. Generally, it's the SHA, or it's referred to as the commit hash. Okay? That's the number that identifies the commit. It's not random, but again, I will come on to that. So if we looked at the Git folder, you'll see that there is an objects folder. And, sorry, if I just go back to my log. And there, you'll see there's one that starts with A7. So ours starts with A7. And in there is the actual commit itself. That's if you put the A7 in the front of it, that would be the entire commit char. That object there is the binary version, or it is how Git stores the commit internally. Okay, but that's what I mean when I say it is actually held to the version, to the repository itself is the .git folder. Yes? Everyone with me? Brilliant. Okay, so cool. So that's basically where we are. We're on a master branch. We've added a commit to our branch. Yes? All golden. So the other great thing with Git is it's amazingly cheap to do branching and merging. It doesn't take much space at all. In fact, it takes virtually no, it just takes bytes to do a branch. Okay? Branches are effectively just labels. So if you're doing a piece of we're going to do a long-running piece of work, and we want to isolate it from the rest of the code base. It's easy enough just to simply branch, right? And we can then play our commits against the branch, and we keep our master nice and clean. Yes? So, Git branch feature. And if I look at the branch list, so just do a straight Git branch, you'll see that I have two branches. One's called feature, one's called master, and master is the one that's currently selected. And so to get onto the feature commit, all I need to do is check it out. And I'm there. So I've now switched off master, and I'm now on feature. Nothing else has happened on my file system because they were actually at the same location. And if I did a git branch again, there we go. It's just simply flipped it. Okay? So now what we'll do is sorry, get my worms in again. I could have done this in one step. So as opposed to saying git branch and git checkout, I could just do a git checkout minus B, which just says if the branch doesn't exist, create it. So where you currently are, make a new label, effectively, and just branch at that point. But that's a nice shorthand. There are loads and loads and loads and loads of shorthands in Git. Far too many to be going over at this stage, but I highly recommend, well, I'll see if I can dig out that link in a bit. So that's what we've done. We're now on our tree, we have two labels. We've got master, we've got feature. And feature is the one we've now selected. So what we're going to do now is just simply create a file called numbers. All right, so on here, what are we doing? Yeah, there we go. So I'm just going to set content numbers.txt. Okay? So I now have a file called numbers.txt. I'm going to add it and commit it. Okay? So that's pretty much what I've done there. So I've added numbers, committed it, and that's what we've done. So we've now got master label is stayed where it is, and the feature label has now moved on one, and that's got that commit associated with it. Okay? You can always go backwards, so I can always unwind backwards, but so feature derives from master at that point. Yes? No one worried by this so far? Excellent. So we're going to add some more numbers. So let's do 20. I don't know why this keeps doing this. PowerShell seems to have a mind of it. The console seems to have a mind of its own as to whether it's going to go into insert mode or overwrite. And it's not easy to change on this keyboard. Right, so git add, git commit, add more numbers. Okay. And what?
Does the dot just mean all?
Yes. Yes, all in that folder. I could recursively do it as well. Sorry, yes. So that's where we are. We've now got a tree that has at least one commit at master, and we're now 2 ahead on the feature. All right? So we've done our feature, we've completed it. That work's done. We don't need we now need to bring that into the master. Okay? Because we're now going to go into a release cycle. Okay? Now notice, in this case, there is a straight line that goes from where master is to where feature is. Right? Now when I do this, I can see someone nodding there. Does this suddenly made sense to you? Brilliant. So if I get checkouts master and git merge feature, because of that straight line, what's going to happen is when the merge happens, the master label is simply going to walk up. It's just going to be moved up because there's no merge needs to happen, right? We already know how to get from master to feature because we just need to walk ahead to. And so that's exactly what's going to happen. And what you'll find is it says it's done a fast forward merge. So right there it says updating, fast forward. And that will give you a nice clean line. So when you go and look at your tree, you're now like that. So all it's had to do is move a label. Brilliant. So it's really, really cheap, really fast. Okay? Wonderful. Right, so I'm just going to quickly reset something. So now what I'm going to do is I'm going to make another change here. So if I make a change to the README file, so I'm going to add that to my staging area and commit it. There we go. Now, so I'm going to do it. What should now happen? So what I did there is I reset head back by 1. And I made a change so that it looked like this. So I'd switched onto the master branch, I'd made a commit, so I still had commits on the feature that I needed to pull over. Now when I do the merge, there is no straight line. There is no straight line straight up from master. It's got to do this recursive strategy. And that recursive strategy means it's going to have to work out what a merge point looks like. All right? And so it will create another commit. And so it ends up looking like that. Right? So this is fine. The only problem is, and it's a problem we tend to find quite a lot in large code bases when you've got lots of people working. What we find quite a lot is that you end up with lots and lots of these merge points. And it can have a tendency to hide what work's been done. All right? Because what you'll find is that the merge point itself is hiding the changes behind it. All right? Because the changes at the merge point will be done by user X. The changes on the feature branch might be done by user Y, but it'll be user X that was seen to have done the merge commit. Do you see what I mean? And that can sometimes help to hide things. So there are ways around this. But there you go. So there's the same thing viewed as a log from the console. Sometimes, though, it's difficult to visualize it from the console. What you might find easier is to use a GUI. In most instances, you'll find that there is a Git GUI installed in the system as part of Git. And what I should be able to do, if I can remember where to do it, where is it? Visualize master's history. There we go. All right? So this is exactly what we've done. So there's the initial README. There's the numbers that I added. There's the point. There's the point where feature forks off, and there's the merge point. So it's where it's come together, and that's a new commit itself. Everyone with me?
When you say it hides features implemented, I'm not quite sure I get you with that. Do you mean it loses them as part of the merge, or it
No, they're still there.
takes one over the other, or I don't quite understand what you mean.
Right, so if you were to annotate the file for looking for changes, so somebody's made a change to a block of code, what you'd find from the annotation is the person who did the merge, not the person who actually wrote.
Attributes the change to
Yes.
the person that's done the merge,
Yes.
not to the actual person that committed
That's
it.
right. That's right. There are ways around that, but it's very easy to miss. All right, and you end up blaming the wrong person. Arguably, you should be blaming the person who did that merge point because, yeah. But it can also make life harder to trace back as well. All right. So at what point in the history does this change actually? Does it come into? Are you going down one branch or going down the other? Okay.
Yeah.
Wonderful. So, you might have noticed when I've been doing this, there is a label that we come across called head. So, who knows what the head is? Anyone? Okay. The head is simply a reference to the current branch. It's the current insertion point. It's the point at which any commits are going to be made. Right? So when you're looking at your repository, in this case, it's a reference to the master branch. But when I switch it to feature, so if I get to check out feature, my head has moved to that commit. Right? Now you can have as many heads as you like, because the heads are simply just the tops of the branches. So you can have as many branches as you like, so you can have as many heads as you like. But the head with a capital, in all caps, is the reference to the current position, your current position within the tree. Okay? And that's all it means. Okay? Any questions?
I know that you have actually color labeled them.
Yeah.
But in real situation, when I have a branch and a trunk, and assuming that we don't have actually, the naming doesn't reflect that, how can I tell whether I am on the trunk or the branch?
What, on master or it's just a label. It is just a label. I mean, so I could, if I wanted to see, I could get branch. So that's where I am.
But that doesn't tell me which, whether master is the trunk, I mean the main trunk or...
By convention, it will automatically be. But it is just simply, that is just simply the name it's been given. You could, you could have a completely different branch. You could get rid of master. But we tend to use, but master is the name that is the name of the branch that will be created when you initialize the repository.
So you go by convention. There's no way.
That's by convention. But I mean, yes, I mean, certainly we have in one of the repositories we work with, the main branch is called Dev, because it's the development branch, and that's the primary that we work against. So there's no reason why it has to be anything else. Okay?
When you do that git branch,
Yes.
is it actually changing the working copy files as well? So we've got different files on each.
Yes. So no. When you check out, so when you check out onto, so when I've done the git checkout feature, so if I look at the state of the files here, right? So on feature, if I look at the README file, the top of that README file looks like that. Yeah. If I get to check out master, and do the same thing, because this is where I added a line at the beginning, yes? And committed it. So that file now looks like this. So by checking out, it will reset your working area to the state of as long as it can, as long as there aren't any conflicts. Okay? Because you might have things at a stage that will cause that problems.
What happens if there is something staged? If you change the BP but not committed it, and then you check out to a branch?
Okay. Let's do it. So, it's okay.
Going to pop down to PC World tonight, buy a keyboard.
Oh, I've got this lovely keyboard. I just need the dongle. Yes, absolutely. Right. So, okay. So I'm on master. I have a change to the README. I've put it in my staging area, right? So now I'm going to git checkout feature. Okay. So in that case, that file would be overwritten, and so it's going to tell me not to do it. Okay.
Can you explain what the difference between committing and stashing?
Aha. I'll come on to stashing if you don't mind. I'll come on to a stash a bit later. Stash is a really, really cool little trick with Git. In fact, sod it, I'll do it now. If you have some changes, so you're doing this, right? So you've got some changes. You want to put this onto a feature, or you have some changes you want to keep hanging around for a very, very brief period of time, but you don't really want to make a commit out of it. Okay, you could make a stash. So just stash the changes, and it's like a stack. So that change has now been pushed onto the top of a stack, right? I can now git checkout feature. So I'm now on my feature branch. The changes have been stashed away. So they had been they've been popped into the stack and removed from my working copy, right? I've now changed, and I can now git stash pop. So I'll pop it off the top of the stack, reapply it, and it's done it.
It's merging it into, it's done a merge now.
It's actually yes, it's actually auto merged it as a change. Okay, it's used a merge strategy to merge the files together. It hasn't created anything. It hasn't created a commit, but that change is now there, and I can now. There it is. So that change is now ready to go. Does that make sense? So stash is incredibly useful. The amount of times that saved my bacon is unreal. So when I needed to, so halfway through working on something, I need to immediately go back to master because we got a problem. I need immediately to branch into something else, git stash it, pop into master, check something out, fine, pop back, go back into my feature branch, pop it, and it's done.
Are stash specifically based branches, or you can actually go through?
Well, notice I stashed when I was on master and popped when I was on feature. It's not tied to a branch at all. It's just a general area within the repository. So it has no affiliation to any branch.
But how do you remember what's in the stash?
Well, hopefully it's not going to be there for very long. I mean, in all seriousness, I mean, you can. I'm not going to go into it now, but you can actually label stashes if you need to, so you can give them names. You know, you could keep them hanging around if you want to. You can list them. You can do all sorts of things with them. But to be honest, I just use it like that when I need to because it's a neat little trick. Yeah?
That's gone off the stack now, is it?
That pops off the stack. Yes.
You'd have to merge back in master then to get the
Yes. Yes.
When you pop off the stack,
Yep.
you're just popping off the delta onto the file. So if your branch had more changes on there and you popped off
You're popping the deltas off. Yes.
just add another new line, what's moving for all sorts of bits in the middle of
That's it.
That's
That's it, which is why it did a merge. Okay, because it's trying to, and if it can't do it, it will prompt you, it'll ask you to correct it, and then you continue. But it does tell you that it needs to do that. Okay? Any other questions on that? Awesome. How are we doing for time? Oh, fine. So, this is worth repeating, and it's worth just drilling into your head. Conceptually, you've got three things when you're working locally. You have your working directory, you have a staging area, you have the repository, right? You check out from the repository into your working directory. So when you check out, you are making changes to your working directory, okay? You are basically taking the state at a point and you are replaying it into your working directory. So they're taking it out of the .git folder and putting it in your working folder, right? You stage your changes to the staging area. So that's where you add, right? And your staging area can be fluid. Generally when I'm working, I will be constantly adding to my staging area. So as I'm working, I'm constantly adding. So every time I touch a file, I'll come back and I'll add. All right, so I'll be building up my index, my staging area, okay? When I'm happy with what I've got, I'll then commit. And that takes the staging area and pushes and materializes it into a change that then exists in the Git folder. Okay? So that is the Git folder. And it's a bit of an odd thing to get used to. But once you get used to it, it's actually quite simple. But so just constantly following the pattern of git add, git commit, git add, git commit, git add, git commit.
So you have to re-add it. So if you change a file in your working directory, you re-add it to the staging
Yes.
area, and then once you've got all of the files added.
Yes, that's a very good point, actually. I'll show that's worth actually showing. So I've got, yes, we'll do this. Let's go back onto master for a second. Okay. Oh. Okay. So I'm back on master. We're in a clean state. All right. And I'm going to make a change to our numbers file. All right. So we're programmers. We don't count from 1. We count from 0. Okay. And I'm going to add that to my staging area. So if I look at the status, my status tells me that I have a modified file. Okay? And if I look at my diff is currently blank because I've stashed my changes. My changes are, the changes that I need to make are in my staging area. I can see what those ones are by adding cached. So I can see the difference between the staging area and the repository by doing a git double minus cached. Okay? So now I'm going to make another change to the same file. And we're going to have line 21. Now look at our status. Would have thought it'd be my history. There it is. Yay. So we've now got two things happening. We have the changes that we've got in our staging area, and we've also got changes in our working area. So you can every time you make a change to the file, you would need to re-add to have those changes reflect. Do you see what I mean? Does that make sense? So I can see the difference between my working directory and the staging area by doing a git diff, and that tells me that there's line 21 is to be added. And then the difference between my staging area and the repository, and that's that. Line 0 needs to be added. Okay? Yes?
If you try and commit it now, will it warn you that you've got undisclosed changes?
Yes. But you can do it. Oops. So, sorry, it doesn't warn you. I've got my staging area done. So what I've got staged, I can commit. All right? So you can break your commits. So the nice thing is you can break your commits down. So you could have a whole raft of changes. You may be changing a README file here, you may be changing a few other things there. You can stage the changes individually, yeah, and then make the commit. Okay? Fantastic. Any other questions?
If you're merging,
yes,
and you made changes in branch,
yeah,
and also separately you made changes in the master,
yes,
and merge them together,
yes,
what happens?
That's where you end up with that merge point.
So you can end up, because I've not done it through the Posh console, but I'm doing it through Visual Studio, which has Get built in.
Yes.
And it does occasionally run into issues where I've been working on a new feature, I've had to go and do a fix on the master.
Right.
And when I've tried to merge them, I've had to go through and select which one.
I'm going to come on to that because one of the things I always like to try and do is I like to end up with that straight line.
Yeah.
Okay? So to try and run that fast forward commit. So we'll come on, if you don't mind, I'll come on to that. All right? Okay. So are we, does this make sense? Does this help to clear up a few things? All right? Wonderful. So, this is the scenario we were just talking about. Okay. So we have master, which is what, and so we had feature that was branched off at that point there. Master has since moved on one. All right, so this is the scenario we're talking about. We've got master has moved on, but the changes you've done in your feature. All right. What we want to do is to change the point that the feature was branched, or otherwise known as rebasing. So you can rebase where the point at which things the point at which things merged, diverged. I mean, okay. Because if we do that, we've then got to straight fast forward again, and that's actually quite easy. So let's just have a quick look at our log. Right, so in fact, we should be at that point. Yes, we can do it from here. So let's do this. So we'll get branch, rebase. Okay, so I'm going to make a branch called rebase demo, and the rebase demo and before I go into that, I'm going to make a change to the master. So I've branched, and I'm immediately now going to make a change to master to move that on one. Okay. Okay. What did I do wrong now? Oh, I've got this, done that again, isn't it? I apologise. Just change my line endings. There is a way I can do that with. There we go. Not on your life. Sorry. There we go. So that's master moved on. Okay? So I'm now going to get checkout, rebase demo. Okay? I'm now going to add another file. Okay? So let's just do another numbers one, that's easier. So, if I check out back onto master and merge that branch, I'm going to end up with a merge point. Yes? Because the two have moved on. What I can do, though, is this. So, git rebase master. And what that will do is it does exactly what it says in 10. Rewinding head to replay your work on top of it. It's perfect sense, isn't it? Actually, that is what it's doing. What it's doing is it's working out where master is, and it's taking all the changes that you have on your branch, and it replays them one by one from where the head on master is. Okay? So it simply replays them as a sequence of diffs again. This is a sequence of deltas. And what you should then end up with is a straight line. Now that will not always work. And what will generally happen is that when that fails to work, when it hits a problem, it will abort, and it will tell you that it couldn't do it. There was a conflict in a file, and it'll get you to resolve the conflict and then just do a rebase continue. So a rebase double minus continue, and it will carry on and play it through. But what we end up with then is that. So our feature is now based off the last point in master, which now means that if I go back to here, it's a fast forward because it knows how to get from one to the other, okay? The nice thing about this is that then when you look at the log, you can see that it's a straight line progression. Yes?
Does that rebase master command only apply to the current branch? that
Yes.
you're
Yes, that's right.
Can you rebase multiple branches at once?
No, but I can't see why you would.
Well, I said if you've got multiple developers working on multiple new features, but then you need to affix in the master.
But this is your local copy.
Right.
This is always your local repository. So you are the only person working with this, right? What you're dealing with is changes that are happening, that are being shared through a central repository, right? That's slightly different. Okay?
So technically, if you develop a feature branch on your software,
Yep.
and you know about the masters that you work on,
Uh-huh.
it's the responsibility of the developer within the feature to be best
Yes.
to make sure it's working with the master
Absolutely.
before you push it to the server.
Well, yes, because is your responsibility to make sure that your feature that you're working on works with the current version, right? What the other thing this helps to do is it helps to force you to solve any collisions, solve any issues at this point on the branch rather than on the main. Yes.
Is it a costly operation because with just one line, it took maybe 5 seconds to do? Does that take a lot of time?
It doesn't take a lot of time at all. It was just simply because it was mucking around with the file system. Actually, it's very fast, generally. I mean, you know, rebase takes virtually no time at all. Because what is, it's how often is it going to muck around with the file system? And so, I mean, if you've got large binary changes in there, it's going to take a lot longer to deal with. But even so, okay? Yes. Is rebasing considered a good idea? I know certain shops that will that say that it's the only way to work. Now, I don't go that far, but I think rebasing definitely has its merits. There are also other things you can do with rebasing, and I'm going to come on to them in a bit, that allow you to alter history, right? Which isn't quite as mad as it sounds.
Why would you choose not to rebase? Because it seems to be an obviously good choice.
There are problems. So the biggest problem with rebasing is that, in fact, can I just see where I am on my slides? Because I do have, right. Let's just go, I'll just quickly just run through this, and I'll come back to it if you don't mind, okay? Fine. So this is the state of the tree before we rebased, all right? We've got these commits. We've got commits A, B, and C, and then we've got D, E, F that are on the feature branch, okay? Now, what the rebase does is it replays copies of D, E, F above the head of master, all right? So it replays them one by one, and then it destroys the originals. So it replays them and then destroys the originals, leaving you like that.
Is that including merge as well? Merge.
Well, whatever was on that branch is now there. Okay, I haven't merged. I haven't merged at that point. All I've done is rebased. Okay, so the problem with this is that the IDs have now changed. The contents of the commits are the same, but the IDs have changed. Now, where this becomes a problem is if you have shared your branch. So if you have pushed your branch up to a central repository, it now means that those IDs have changed. That's where the problem comes in. So generally, this is something that I do locally, and I will do it on a local branch that I haven't pushed, right? So that is the problem with rebasing. You can get past it because you can simply force it, but it's not considered very good practice. Okay? So, interactive rebasing. I put this here just so it would remind me to do it. Okay, interactive rebasing, this is fun, for various different definitions of the word fun. So, what I often do is, especially if I'm working on something that, let's say I'm working on a large code-based refactoring, okay, I will have lots and lots and lots and lots of very, very small commits. Yes, because I want to be able to unwind at any point. So I end up with, on my feature branch, I end up with a massive laundry list of tiny edits. Yeah? So we're going to make a massive laundry list of tiny edits. So let's check out tiny. Sorry, create the branch. Okay. So what we'll do is we'll say, I'll do this all in one file, but it'll make sense. So let's say line 1. And we'll say small txt. Okay, so git add small txt text file added. Doing it the wrong way. There we go. So git commit file added. All right. So I've got a commit there that simply adds that file. I'm now going to add a second line to that file. Oh, God's sake. Add it. And we'll commit it. We'll just simply say file changed. And we'll add a third line. I think you can see where I'm going with this. Right. So, from the code-based perspective, on master, the fact that that file's been changed 3 times is irrelevant. That was only useful to me on my local feature. Now I've done the work of my local feature. Actually, the only thing I want is the combined changes, right? So what I can do is I can do an interactive rebase, and this is rewriting history. This is the fun bit. So whereas I did, God's sake. What on earth is going on there? Go away. Something really weird and wonderful is happening here. What the hell?
Numlock on your keypad.
I'm just going to quickly, we're just going to start a new instance. I bet you can't see that, can you? Hang on. Let me just, it's probably the PoshGit extensions have got a bit confused. Sorry, let me just shut it down. I'll just, properties, font, make it slightly bigger. I can't wait to use the proper command prompt in Windows 10. There's so much difference. Anyway, right. So I should now be able to go into, which repository are we in? We're in demo, aren't we? No, it's not. Right, there we go. So, there we go. So tiny So that's where we are. That's where master is. And we've got these 3 changes here. Really, I could do with them being the 1 change. Yes? So I'm going to do a git rebase -i, which is short for interactive, against master. And what this will do is this will bring up a text editor, whichever one I've defined in my shell, and it will allow me to alter history. So there are the 3 commits. File added, file changed, and another change. And I can pick, reword, edit, squash, fix up, and exec. So let's say I want to squash them all together. I could just simply say change pick to fix up. Like that. Okay? And when I save this file, Git will then rebase in the same way we did before, but now it will fold them together. And it's done it. Successfully rebased and updated. Now if I look at the log, it's 1 change. And they've been merged together. You can do lots of things with interactive rebasing. So let's say, again, as I was saying, I've got lots and lots of small changes. I could drop one of the changes from that feature. Yeah? If I know that something 5 commits down, I don't need it anymore. Interactively rebase it, take that line out. And when it replays it again, it replays it without that change. So especially when you're doing, refactoring work, when you're doing lots and lots of small changes, and you want to be able to move back. But once you've finished that work, you want to squash it down, can turn it into a smaller set of commits. And now, when I do the merge, I've just simply got to fast forward at that point. Does that make sense? There's a couple of people that are certain about that. Okay, any questions?
So just to recap,
Yes.
if you didn't do it interactively, you would just get all the separate.
That's it.
It's just shunting it.
That's it. Yes. There is also a feature, but if you know that's what you're going to do, if you know you are going to fix up or squash, there is in fact I think it's an exclamation mark. You can prefix the commits message with, I think it's exclamation mark fix up or squash. And when you do an interactive rebase, it'll automatically have it set up to do it. All right. Okay, so that SHA that we were referring to earlier, and the reason why it was a problem, the SHA itself is calculated from the commit. And so it's not random. It's calculated from the diff itself. It's also calculated from the metadata around the diff. So things like the author's name, the time and date. Okay? It means that there is a deterministic way of reaching the number. Okay? But this is why the SHA changes. So when you rebase, that's why it changes, because the metadata has changed. Because one of the things it keeps a record of is where it's come from. So the metadata about the change will include what its parent's change was. And if its parent has changed, because if you've rebased from the point that you've initially branched from, the first parent has changed. Therefore, that SHA has now changed, which therefore means its child SHA has changed, right? Does that make sense? Okay? That's why there is a problem when sharing or when rebasing against a branch that you have actually pushed up online. So, cloning repositories. Remember I said before that when you're working with a repository, you're working with a complete clone. Yeah? Well, I took the liberty earlier of getting the TypeScript code base from GitHub. Now, I'm not going to bother, but I could completely disconnect my network at this point. But that one line, decorate. No, I can't type. All those changes, every single one of them, has been pulled down from GitHub. And they're on my local file system. So I can do whatever I need to do with that file system at that particular point in time. I can check out, I can branch, I can do anything I like to the repository, and it's all here. Right? It is a clone for a reason. So when you think of what you do to initialize a repository or get a copy of the repository, you do a git clone. It does exactly what it says in the tin. It's more than just simply a subversion checkout. This really is take everything. So everything that's on the everything that's up on the web, take it, and move it locally. Yeah. I can clone from any point. So I could git clone. So there's our demo repository. All right. And I'm going to clone it to demo clone. I've now made a clone of my demo repository. Wonderful. Nice and cheap, so I can simply go into demo clone. And the log is exactly the same. All the shards are the same. All the commits are the same. Every binary object, every object within that repository is identical. Okay? So what I can now do, if I just check, yeah. So because I cloned the repository on my file system, so I cloned demo into demo clone, what it's done is it's set up this thing called origin, so where it's come from. So I can now make changes to my clone, and I can push them, and they'll be reflected in the original, right? Let's. Okay, so I've added a file called slave. If I get, I'll put it on master. Okay, git add. So I'm in the clone, right? And the file slave exists as a commit to the master on the clone. Yes? So if I change to that folder there, it's not there. And if, in fact, more to the point, if I check out master, it's not there. All right? Slave doesn't exist in the original. So, what have I done?
Just currently checked out.
Say again.
You checked out demo branch.
I have checked out demo branch, demo clone. Updates, I default. Yes. Sorry, but I should have done, my apologies, what I should have done is should have done this against the bare branch. Because this is against a live copy, it would muck things up a bit. Sorry, that was a bad, that was a, yes, that was not a good demo. I'll come back to that, sorry. I had forgotten to set that up properly.
One question about
Yes,
you edited the file
yes,
in the clone,
yes.
didn't add it to your staging anything. You checked out master, and it didn't say anything. It seemed to suggest that the file just magically stayed there.
Oh, I see what you mean. Yes, because I switched branches, but because there would be no collisions at that point, that file could stay unchanged. Oh, that file could stay changed, and then I could add it in the branch. Because it wouldn't have an impact.
So if you haven't told Gil about it,
You can switch branches, right? And as long as it's not going to do anything like remove the file. If it's going to start doing things like removing the file or making modifications to the file you've modified, then it's going to start complaining about it. And it's going to want you to confirm to do what you need to do. Okay? So, just quickly going back to this, there's only a couple of things you really need to know about from the perspective of working with the remote. So adding to our checkout, stage, and commit, we now just need to be able to push and fetch or pull. I try not to pull, but because I think that's a shortcut.
Can you explain the difference?
Yes. So a pull will modify your working directory. So when you fetch the changes into the repository. You fetch the changes into your Git folder. When you pull, you fetch the changes into your Git folder and you make the changes on your working directory, right? What I prefer to do is pull the changes into the Git folder and then I will rebase, right? Or then I will pull at that point, or I'll do a pull double minus rebase. But I very rarely do a pull, because unfortunately what can sometimes happen is you sometimes end up with a merge point directly just because you've pulled, right? So that just helps to get around that, okay? Other useful things you can do, cherry picking, for example. So if you've got say you're working on a long running feature branch, you have a change in that feature branch that you suspect will be useful. You can easily cherry pick. So if you've got, so let's have a look. Where am I? I'm on. I'm on a slave file, aren't I? So if I was to check out, sorry. Okay, so let's say I'm on, let's say I go on to feature. And I want the change, that one there, this changes ... Okay? I could git cherry pick. Whoops. Which one do I want? 6E0EDC3. Yeah. So 6E0EDC3. Okay. So I've taken that change. What it will do is it basically it copies that commit and plays it as its own commit over the top of where you are, all right? That obviously will have its own brand new SHA, all right? In fact, you can see it there. So it's got its brand new commit ID. But in the cases where you have got something that's isolated and you need to quickly bring it on, you can simply cherry pick across branches.
And when you bring that, sort of rebase that, whatever, does it work out that it's already committed that?
It will just see the fact that the two files have been modified in the same way.
Right.
So and it will attempt to ignore the change. Because if it can see that the end result of the files are the same, it'll jump it. All right? But no, it doesn't actually know that that's where it came from. Okay?
So the cherry pick.
Yep.
So the hash is just telling exactly where to pull it from.
Yes.
It doesn't say which branch or anything.
That hash identifies where it is. Okay, so anywhere within that tree system, that hash is the identifier. Okay, because actually you can have multiple branches, multiple labels pointing that all contain that ID. Yes.
To be clear, it's the cherry pick just that particular change.
Yes.
Just that delta.
Just that delta.
Delta.
Nothing.
Gets you to that.
No. Just that one change. Okay. So there are occasions where that's really useful. So you've had an emergency patch that something's in production. You need to emergency patch that out, and you've worked it out in a feature branch. You can pull it straight over. But it is a copy of, right? It's not the same thing. It is a copy of, and it's been replayed over the top of. So you may end up with a merge error, right? So you may end up with a collision that you have to resolve. So they're not the same things. Okay, it's a copy of.
So is there an opposite of cherry pick? Is there a
Opposite of cherry pick.
Sorry,
Well, yes, you could, because you could interactive rebase and drop a commit. When we did that interactive rebase, we get the text file and it asks you to pick which changes. So we picked one and then we've squashed up, we fixed up the other two to produce down to one merge.
but that you have to be on a branch to do that.
Yes. Yes, you'd have to be on the branch.
This is the master.
In which
you're on the
case-
master thread, you're on the master
Right.
branch in the master repository.
You could revert a change. So you could revert the changes that exist within a change, right? And so basically replay the reverse against your file system, right? And then commit that. So you end up with a reversion. Does that help?
Yeah. But that's not a cherry.
It's not a cherry pick, no.
That's something else.
No, I don't know how you cherry pick a negative item.
Yeah.
It's sort of a anti-cherry pick. Okay, yes,
What if you want to move a couple of commits to a separate branch?
right. To move them to a separate branch.
So you committed something to master and then you realize that you want to do a separate feature or something like that.
Okay, so there are ways of dealing with this. If, for example, you wanted to, what you could do is, if let's say you've made changes to master and you haven't pushed them to the outside world, right? You could branch at an earlier point and you could rewind head. So you could git reset head ~2 to move back twice, and that would move. So you could set a branch at the current point, right? Switch to master, and then move the head back. That would leave the branch that you've created at the point that you wanted those commits in, and head would now be back to. Does that make sense? So yes, you can do it that way. But be careful when you're doing things like that. I mean, you can always, the nice thing with Git is you can always get back. So if you do make a mistake, have a look at ref logs. So there is always, you can always get back to where what you just done.
But you have to push the branch.
When you've pushed, you're now in a position where you've now shared the shards with the outside world. All right. That point, you now don't want to be doing things like this. When you're working locally, if you are ahead of origin, these things are fine because you're only doing them locally. Okay. So just as an idea of how you can set up a workflow, this is the workflow that we're currently using at my place of employment. So for all for every API that we deal with, we have a global repository. So we have a global GitHub repository for the API. We can then, each developer has their own personal fork. So each developer has their own personal fork of that API. And then they clone that personal fork to local. So that's the version they're working on is in the right-hand column. So it started from global, been forked since now on local. Yeah?
Can you explain what a fork is?
Right.
In Git terms.
In Git terms, a fork is saying, here is a code base. I want a copy of it. And I'm now going to start my work from that point.
How is that different from a clone?
Because in GitHub land, when you fork, you are setting things up so that it knows where to go back to. So it's forks from a repository. So you're cloning, you're forking a repository. Yeah, it's like a clone, but it's a clone up in the server, right? So the first two are on the servers, are in the cloud. The third version is local. Okay? So you clone from the fork locally.
There's also, I think, an intermediate state when if you push things to the forking repository, the person's got the repository.
Yes, that's it. So you set the mechanisms by which you can generate pull requests. But I will come on to that. Because what we then do on a daily basis, we fetch and rebase. We fetch and rebase from global. So any changes that other developers have done, we pull from the global. And all the shards will match because that's where it originally come from. And then when your changes are done, you've worked on the feature, we push to the fork, and we've got Team Sissy set up with GitHub integration, so that will immediately kick off a build. So that'll immediately kick off a CI build and immediately run all our tests. And if that goes green, we can then run a pull request. And that pull request then notifies the maintainer at the global level, and they will then pull the changes in to the global repository. So then all the developers can then get access to it. Yeah? So that's quite a nice way of setting things up if you can get things. Yes?
So does this kind of assume that each developer is working on kind of a feature on their own, or do you work in teams? Would you have like a team fork?
We can do we sometimes do team forks as well. Yes. But yeah, generally you'll be working on something. If you're working on something small, yeah, okay. Yes. But yes, there's nothing to stop you working that way. Okay. Just a quick thing about line endings. Be aware of line endings, especially when you're working with cross platform dependency. So if you're working on a code base, and for example, you've got iOS developers, OS X developers, Windows developers. The problem with line endings is generally because of Windows. Windows stores line endings as CRLF, and most other sane operating systems store them as LF. Now, what Git will do is if you've got a global setting set up with core auto CRLF to true, when you commit, so if you've got a file in Windows land that ends in CRLFs, when it commits them with LF. Right? So it will take the, so if all the line endings are CRLF, it will change them when it commits. And that changed version is where the SHA comes from. So the SHA is calculated on the version with LFs, not the version with CRLFs. Which therefore means that when you're on another system that uses LF as line endings, it'll simply check out as is. But on a Windows machine, it'll attempt to rewrite it again. Now that does sometimes present issues. Sometimes you'll find that if you've set auto CRLF to true and you check out and you grab a copy of a repository, you suddenly get this list of files that it claims you've changed. Right? You haven't. You've merely copied them out. But in the process of it writing them into your file system, it's taken a look at the line engines and gone, they're all LFs, they need to be CRLFs. Copies them back, recalculates the SHA, it's changed. So they're now different files. And it will then moan at you to say that you've made changes. So it's just something to be aware of. I think we're nearly there. This will be on the slides. This is a seriously good précis of what of the different processes within Git. So you pull from remotes into so the pull goes straight from remotes to working files. Branches you check out, you fetch from remotes into clones, and so on. But that's well worth printing out and getting used to. Once you get used to it, it's really easy, but there are enough pitfalls to start with to trap the unwary. And I think, oh yes, I was just going to quickly say, there are loads and loads of GUIs and front ends that will make life easier for you. My advice is to use the command line tools, but you, alongside the command line tools, use a GUI as well. So use a GUI to show you what you've done, right? Because once you can visualize what things, if you can visualize the changes, it makes life a lot easier. My personal favorite is Atlassian Source Tree. I think it's a really good product, and it's free. But yes, so 99% of the things that I will do from the command line. There are a few things that I'll do from a GUI because they're just easier. But it's worthwhile knowing what's actually happening under the hood in the first place. Okay, and I think we'll leave it there, unless there are any questions. Yes?
Sorry, you didn't quite, well, I'm not sure I missed it, but I wasn't sure about like, sort of the closing off of the feature.
Right.
I was sort of, because I quite like tidying things up, so I wasn't sure.
Oh, once it's done.
Merge it all back and delete the feature branch, or whether you could.
Yes, so the branch itself is just a label. So yes, if I needed to. Yeah, I mean, if I get checkout master. So if I just look at my branch list, I've got all those branches. I could just simply git branch, delete, feature, done. Helps if I type properly. Done. Gone. So it's just all it's done is remove the label.
Right.
That label's gone. All the commits are still there.
Okay, and so all that history, all that comment,
All there. All there. It doesn't lose things. All right, it's not. Otherwise, it would.
TFS, you delete a branch. Gone.
Yes. Well, that's TFS for you, and it goes to show why Microsoft themselves are moving lock, stock, and barrel towards Git. Any other questions?
If you have two branches,
Yes.
I think someone touched this earlier, but I didn't quite follow. But if you have two branches, you change one, you want to change the period branch, can you merge that branch back into the master and then rebase this?
You could rebase at any point. There's no reason why you have to rebase against master. Right. Master is just a label. You could rebase against a specific commit if you wanted to.
So you can take those changes, put back in the master, and then send them back into
Yes.
the new branch.
You could do it that way, or you could just avoid master completely.
Yeah.
So you could say, if you've got two feature branches,
Easy in my head, but use the
But you could, if you had feature 1 and feature 2, you could rebase feature 2 off feature 1.
Okay. That's cool.
It's just a label.
Yeah.
That's all it is. Any other questions?
Possible to use interactive rebase that you already push and to push it again?
Yes, you can. Yes, so you can always do this. The problem, Git will warn you that you're about to do it, and you have to then force it. So you will then have to do a Git push force.
But what happens if other developer already push? Already pull?
Well, that's the problem. That's why you really need to be knowing what you're doing. Because you then have to basically talk to other developers and say, look, you're going to need to do a pull at this point, and you're going to need to force a pull on it. Generally, don't do it. Once you've pushed, don't do it. All right. If you're sharing a branch via Origin or anywhere else, just don't do it. It causes too many problems. If you need to, make a new branch. They're cheap. They cost nothing to do, and just say to other developers, look, that branch is gone. It's not useful anymore. Yeah. I mean, branching in Git is so cheap and so fast. That's what you should be doing to start with. Yeah? Excellent. Any other questions?
Push and pull.
Sorry.
Confirm something. So when I've got a local copy from a remote server,
Yes.
I want to commit those changes to the remote server, I push it.
Yes.
But when I've got a fork from another repository on the server, I want to push those into the global repository.
Mm-hmm.
I do a pull request.
Right. So in GitHub, there is an open source project that you want to contribute to. All right. Generally, the process is you fork, you make your changes, you commit to your fork, and in the interface there will be the option to make what's known as a pull request. The owner of the repository you forked will then get a message to say, user Y has just committed these changes with this message, right? Do you want to use them? And they will be given the option to be able to pull those changes. So it's a pull request. So do you want to tell the notifier, to tell the owner that they could make a pull from your repository? Yes? That's why it's a pull request. Excellent. Any others? Yes?
Do you manage tags like branches?
Tags are, yes, I mean, you can add tags at any point. So you can add a tag, at, on any commit. We often do it so that build servers, for example, we tag a build number on the master branch, on the completion of a successful build. So that we can then track back to the exact build, so the exact commit at the point that we've got to build. All right? You can have as many tags on a commit as you like. They're like sticky labels. You can have them and you can move them around. Okay?
Sorry.
Yes.
Another couple. So pull requests, is that a purely GitHub thing? Or
Yes.
So if you just get yourself Git, start working on it, then
It's set up. It's a GitHub thing. I mean, Bitbucket do it as well. It's the same. It's the same principle. It's called the same thing, and it's just done with hooks that can be set up on the server. Okay.
and yeah, the other thing is, are any of the IDE tools to manage Git worth looking at, or is it better to stick with command line and a separate?
That's what I was saying. I think you understand a lot more about how Git works, and therefore you're much more able to solve any problems that arise if you understand from the command line. But I do, from my day-to-day work, I use source tree, because source tree is I can then see immediately what's going on. I get nice graphic, nice graphs, and I can just double-click on a branch name, and it just sorts things out for me, and also allows me to do nice things like partial commits. So if I've got a file where I've got, say, 2 sections of the file that have been changed, but I want them to be done as separate commits, right? Things like source tree makes that easy. You can do that from the command line, but it's much harder to do, yes. And so I tend to do it. The other thing, one of the other nice tricks in source tree is you can get it to show you the commands it's actually doing under the hood. So you can pop up a command window, and actually, so any operation you're doing, it'll actually show you the git commands as well. That's quite nice. But I don't work for them, so. Excellent. I think it's time for coffee. I'm around for the rest of the day if you need me to grab me. And thank you very much for attending. Make your changes and you commit to the changes, right? In Git, you stage them. So you have a working area, so your folder. You have this stage, or sometimes referred to as the index, or even the cache. The terminology is used interchangeably, where you put together what your commit will look like, right? And then you commit that. So what I'm going to do is I'm going to add this file to my staging area. Okay? So I'm going to do that with git add readme.md. Okay? Now, LF would be replaced by crlf and readme.md. I will come on to this. This is something that bites a lot of people. But I will come on to this. For now, just accept that that's okay. And what I'm going to do is git commit with a message, and that message is going to be add readme. Sorry, hang on. Yeah, I am going to need to. Sorry, bear with me just 1 second. Where's my folder gone? So this is a problem to do with line endings. And that ebooks, I hadn't realized, does something nasty with it. So I'm just going to quickly reset the encoding on this. Encoding, where are we? EOL conversion, there we go. Windows format, save it. Okay, let's add that again. There we go. So the prompt here, my posh get prompt has gone green. And what this is saying is that I'm on branch master, I have an initial commit, and I've got some changes to be committed. Okay, so my staging area now has, so this virtual idea, this virtual stage, now has a file that will be committed when I do the commit. Okay? And so I'm just going to make that commit done. So it's inserted the file. Right then, well, we might as well crack on. So, behaving like a Git and getting away with it. How many people here use Git in the day-to-day environment? Brilliant. How many people think they understand how Git works? A couple, okay. How many people get scared by Git? That's what I thought. So the whole reason why I put this talk together was because I kept on going into environments, kept on working with developers who were scared to the back teeth of Git. They get it dumped on them, management turns around to them and say, right, we're doing everything in GitHub now, or we're going to use Bitbucket. And the developers turn around and go, yay? And they're expected to understand how the thing works to start with. So that's the level of this talk. What I want to try and do is demystify the processes behind the scenes, and hopefully that'll make life easier to work with. Okay? So I am a technical architect and evangelist. Those people who've seen my talks before will know this, will have seen this bit before. I've been developing for way too long. Properly started on one of those before migrating to one of these. Then moving on to one of those. Awesome. Mega, fantastic machines. And then made the giant leap forward to, yeah. Anyway. I'm a very, very infrequent blogger. It's more often than not you'll find tumbleweed, but I mean, if there's anything there that you find useful, please knock yourselves out. But don't expect any updates for very extended periods of time. So, what is Git? Well, in its basic form, Git is a distributed version control system. But you already knew that. So what do I mean by distributed version? Well, who here has come from a background of using things like Subversion, right, or Team Foundation Services? Brilliant. So the difference between Git and TFS is it's disconnected. Git, when you work with Git, you are working with a complete copy of a repository. Whenever you grab a repository down from the internet, you are grabbing everything. You are grabbing all the history, all the work that's been done to it, and you're bringing it down locally to your machine. It's completely disconnected. Unlike things like Subversion or Team Foundation Server, where you are liaising with a central authority all the time. Okay? So in Subversion, you check out a copy of the code at a point in time. You make your changes, and then you submit those changes. So you submit the delta. With Git, you do it all locally. So you pull everything down, and you make your changes in your local system, and you may or may not want to share that with the outside world. But the great advantage is that you could be on, once you've got the repository down, you could be sat on the train with a rubbish Wi-Fi connection. You don't need access to the outside world. You can traverse through, you can branch, you can do anything anything you need to do is done locally on your local file system. Okay? So it was created by Linus Torvalds. The Linux kernel codebase was originally being maintained in a system called BitKeeper, and there was a falling out with regards to licensing issues. So he used BitKeeper as a basis, as an inspiration, along with things like Monotone, to produce this distributed version control system. So Linus, being the nice, friendly person he is, yes, it has all the hallmarks of it being slightly obtuse at times. So how do we get started with Git? Get in it. That's it. That's the only thing you need to know to get going. When we do a Git init, so a Git init repo, for example, we create a folder, and in that folder there will be a .git folder. So effectively what we end up with is a structure like this. So you have a folder, and inside it there is a magic folder called .git. And that magic folder is the repository. Okay? That repository right there, that's it. So all the history and everything else is going in that location. Okay? So
Is that on the server?
it's on wherever you're doing it. So for example, here I have a PowerShell session, and I have a few things in there. As for the status of the repository, it's empty. There's nothing there. There's nothing to commit. We're a completely blank working copy. So if I do this here, so I'm in my demo repository, and I'll just do a git status. This command you'll get to love. Okay? Notice that the typo was a deliberate mistake. Git does actually do quite a good job every now and again of trying to work out what it was you were actually typing, and will attempt to prompt you if you've got it wrong. But anyway, so the status is telling me that I'm on the branch master, on the initial commit, and there's nothing to commit. Okay. So what we're going to do is so that's our state there. So imagine this as a tree growing up from the bottom. That's the state we're at now. We're at a, sort of an initial node. Okay? And what we're going to do is add another commit to it. So we're going to add another step to the tree. Okay? So, this is easy enough. Let's just, in fact, where's my snippets file? I have my favorite thing in the world at the moment, which is horseebooksipsum.com. If you want any, yes, this is genius. If you want any, Lorem Ipsum's so 90s. If you want anything decent, use a horse ebooks. See what I mean? So I'm going to pipe this through into a README, because that would make sense. So here's the contents of the README file. Okay, it's complete gibberish, it's brilliant. But it looks fairly real. So I have a README file. Now if I look at my status, it's telling me I'm on branch master, I'm on the initial commit, and there is an untracked file. There's an untracked file called readme.md. So what I need to do is I need to track the file. I need to put it somewhere where I can stage it before it gets to commit. So this is the other major difference between working with Subversion TFS or Git. Generally in Subversion, you would, so let's Git init demo. Done. So my machine now has a fully initialized Git repository sitting on the machine. And I can go, sorry, and I can go into it. And with the PowerShell extensions I've got installed, so I'm running the posh Git extensions, it tells me that I'm on the master branch. Done. You can see this, so there is the Git folder there. Normally it's hidden. But that's it. That's where it is. And every commit, every operation that you do actually happens in there. So you can also create, this is a normal local working copy. You could also create a bare, so I could do this. And, sorry, I should have actually done that. By convention, when you do a bare one, you call it .git, like that. And what you've got here is a raw repository. So this is where you would normally get what you would normally store on a server, where you're not actually doing any local work. So a bare repository is just the commits. It's no working version. But generally, locally, you simply start with a working copy. Okay? So you just do a Git in it. If you've already got a tree structure, if you've already got a location that has all your source code in it, just do Git in it. So you don't even have to create it will create it in place for you. So let's say I had a just go into existing, and I can just Git in it at that point. And I've just done it again. So there we go. Creating repositories is simple, is incredibly lightweight. You can do it for anything. Do it for your PowerShell scripts, do it for your modules, do it for your local home folders, do it for anything. Anywhere you think that you might need some source version control, do it. It takes seconds. Yeah? So, we've got our folder. It's got its magic Git folder in it. So let's put some stuff in it. In this case, I've just simply asked